Of course, we know that aluminium is at the moment still abundant in terms of natural resources. Bauxite reserve estimated 40 to 75 billion tons. However, the problem with aluminium is that especially the primary production, is that the energy consumption, refinement of the bauxite, smelting needs a lot of energy, large amount of energy. And therefore, what we're trying to do in the future is that we're trying to reduce the primary production, and then we try to mix it with the secondary production. And this is where the idea of circular economy will go to place. Yeah. So, but before we move on to circular economy, we want to see what is the economy that we have at the moment. Yeah. So the economy, or the industrial economy that we have at the moment, is the so-called linear economy. And this is the reason why it's called linear economy, because the rate or the patterns of consumption is more or less linear. So we take the natural resources from the Mother Earth, we create or we manufacture it into something. In this case, is aluminium bar, and then from the aluminium bar we make aluminium cans. So not drink the cans, obviously, drink the Coke in this case. But once we finish with the drinks, we throw away the cans. So this is the disposal. Again, this linear economy model is a classic economic model that encourages short production life so that we can buy more due to the availability of cheap and easily accessible materials and energy. And this is also this model is also called cradle to grave. Obviously not sustainable. So what's sustainable is that once we have finished or we've drunk the drink, then we collect the cans, and then only if it is possible to reuse it, then we immediately reuse it. If not, perhaps we do a bit of repair of that, and then if we can repair it, we continue the loop until we reach the recycle loop before we are dumping it to incineration. So this is the idea of the circular economy, because we are trying to reuse, we are trying to immediately use the end-of-life product and bring it back to the circulation. And this is called the circular economy. So the circular economy, as opposed to linear economy, is an industrial economy that is restorative. So we can restore, and also regenerative, because we can regenerate. There are three principles of circular economy. First one being minimization of the consumption of raw materials, or finite raw materials. So if we do not need the product now, we better delay it, because when we delay the production, we minimize or we reduce the consumption of the finite resources. However, we need it if we want to make, if we want to produce, then we want to produce it at the rate that we need. And more importantly is that we use the product at its highest utilization and value. And this is done by maximizing their circulation. So finally, when the product reaches end of life, we try to minimize the content of that product that will go to landfill or incineration. This way, we will achieve the so-called cradle to cradle. Talk about circular economy. I suggest you to look into a website called the Ellen MacArthur Foundation. Dame Ellen MacArthur is a an ex-British athlete who is also the proponent of circular economy. So she established this foundation to promote sustainability through circular economy. So they invented these diagrams to illustrate how circular economy can be implemented or adopted by looking at the two types of materials. So the right-hand side, the blue colors, you will see that these are the third cycle or the circle for the so-called technical nutrients. Technical nutrients means all the products that we use, the product that we can touch, mouse, mugs, mobile phones, for example. So these are all considered as technical nutrients. On the left-hand side, on the green color, you will see the so-called biological nutrients. It means that this is something like liquid gas, something that we do not touch or we do not use as equipment, for example. And because we have two different types of cycles, now let me go first to the technical nutrient cycles. And this is the main principles of circular economy, whereby we produce spare parts, and then we produce the product, and then we deliver the product to our customers, of our users, and then we try to maintain this product so that the product can be used longer in circulation. Yeah. So the maintenance is part of the circular economy, and then we have this reuse or redistribute, refurbish before it's been recycled at the beginning of the process. Yeah. And because it is technical nutrient, then it is possible that we can do this kind of reusing, recycling, refurbishing, and so on. On the left-hand side, however, we won't be able to do that because we are not dealing with technical nutrient. We are only dealing with biological nutrients. And therefore, the focus of circular economy on the left-hand side of this butterfly diagram seems to be on different things. So, for example, on the cascading use. So, whenever possible, a product, when they're about to reach their own, the end of life, they need to be transformed into some other products. Yeah. For example, food products, fresh vegetables, chilies, for example. So you have chilies almost ending end of life. We can preserve it, we can froze it, or we can turn it into another product, for example, chili powder. And that way the value of chili will be retained. The value of chilies will be retained. So as opposed to being thrown away because they are reaching end of life, they are going to be turned into chili powder. That's the focus of the left-hand side, cascading use of product, and also waste reduction. So whenever possible, we're going to reduce the waste. Yeah. Again, by turning it into some other products, we also inherently reduce the waste. And finally, if we can turn, if we already have waste, what do? It would be nice if we can turn those that waste into energy, for example, using anaerobic digestion. So this is the kind of project that Dr. Cindy mentioned very early in this presentation, that Coventry and in the UE was working in this project in the past. So on the left-hand side, cascading use, reducing waste, reducing pollution. So these are the main focus of the left-hand side of this butterfly diagram. Okay, so moving on. About 2019, we carried out research to enhance our understanding of the CE values, so the value of CEs. And here we identified 3 different tenets or values within the CE that are critical to the success of adoption or implementation of CE. And these tenets are called principles, attributes, and also enablers. So principles are all the essential activities or guiding rules that we need to follow to implement circular economy. So for example, as I said before, we need to think about cascading orientation. We need to think about waste elimination, economic optimization, maximizing of retained value, environmental consciousness, and also leakage minimization. So these are considered as the principles of circular economy or the guiding rules when we adopt circular economy. And secondly, attributes. Attributes are the natural characteristics. So characteristics of the products that we want to circulate, we want to apply the circular economy to. Although we know the principles, but if the products are not designed in such a way, are not produced in such a way that support the circular economy, then it would be very difficult for us to reuse it, to recycle it, to refurbish it. And finally, in addition to the principles and the attributes, we also need some enablers. So enablers, for example, the technologies, the market, yeah, and also the different types of innovation that we need to do to that particular product. Here's an example of the principles. Like I said to you before, this is the cascading principles. So when the first user finished with the product, instead of throwing it away, yeah, then the product is passed on to the second users. And then after the second user is finished with that product, the product is passed to the third users and so on. So this is very, very typical in agri-food supply chain, because again, we are dealing with non-technical nutrients, and therefore the principle of cascading is very, very suitable. So for example, the main products of these agri-food production is going to be, let's say, fruit and vegetables. And these fruit and vegetables are going through the distribution channels and then sent to the modern retailers, supermarkets, for example. But those products that do not meet this specification or cannot be sold in this market, they can be sold to different channels. So maybe they're sold to traditional markets. If they cannot be sold in traditional markets for whatever reason, then it may be sold to a food processing industry. Tomatoes, for example, can be sold to ABC or Heinz. They can do a ketchup or tomato sauce and so on. And all of these cascading mechanisms has to be planned and has to be designed in such a way that it can reduce the waste of these products. Attributes. An example of attributes is this, the circularity. Circularity means that the products should lend themselves to circular process. It means that they have to be designed in such a way that circular economy can easily be done on that particular product. So for example, if this product, this is a dental floss. This dental floss is designed in such a way that the disassembly process can be done easily. And in this way, then this plastic part can be recycled or can be reused immediately, maybe. Finally, enablers. So an example of enablers is technologies. So in order for us to implement circular economy, we need technologies. For instance, if we want to extend the life of these printers, then we need to be able to sense, or we need to be able to know when the printer is likely to be serviced. So before it breaks, we provide spare parts timely, so that the printer so that we can extend the life of the printer, and therefore we can minimize or we can reduce the consumption of raw materials to produce or to manufacture new printers. So the idea here is that we use technology to extend the life of this printer. Okay, so that's the first part of my presentation. Now we move on to the second part, which is the impacts of COVID pandemic on supply chains. The third part of my presentation then will then look at how circular economy will be able to help, will be able to open up ways of opportunities, particularly post the COVID-19 pandemic. So take a look at supply chain. So supply chain can be simply defined as a set of 3 or more companies, so these are all companies, linked together by one or more of the upstream. Upstream means the suppliers of this focal firm. Typically, the focal firms are the manufacturers, because we're talking about manufacturing products or supply chain products, and therefore the focal firm is the manufacturer. And then the product being produced will be distributed by the so-called distributors along the channel of distributions before reaching the retailers, where the customers then can buy the product through these retailers, for example, supermarkets, warung, toko, and many other types of retailers. But the goal of supply chain here is that we're trying to match the supply and the demand. So whatever the customer demands the product, then the retailers, distributors, the manufacturers, and the whole supply chain needs to be able to meet the demand of that customers. Talking about the supply and demand, let's take a look at what happened during April or March 2020, where the first time we had this pandemic. At that time, of course, the virus must be contained. Everybody was really worried about hygiene. They all want hand sanitizers, disinfectant, PPE, face mask. Social distancing needs to be done. Workplace surface sanitation, traveling restriction. We have work from home, lockdown, everything. But the impact of this is massive in terms of supply chain, because everybody wants bread. Then obviously here in the UK particularly, suddenly everybody buys in large amount of bread, large amount of toilet rolls, toilet papers, a large amount of gel or hand sanitizers. So this panic buying is actually impacting the supply chain, because if you look at this, is everybody panic buying at this point, the supply chain will not be able to meet the regular demand that they are supplying in the regular pattern. So these are all the pictures in the UK, and I'm pretty sure in Indonesia are going to be the same. So the impact on retailer, obviously, in the supplier, customers are doing panic buying, erratic demand. Erratic means random. So the change of customer habits. They are, in addition to going to the supermarkets, they are doing online. Consumers buying long life products, food. Consumers buying raw materials. Retail reduced variety of product. So all of these create the disturbance to the next part of the supply chain. In this case, the warehouse. So the warehouse has to be able to meet the sudden demand, the erratic demand, the random demand of the supermarket or the retailer. But the problem is that the warehouse itself, there's a lot of restriction in the warehouse. Yeah. For example, the safety distance, which means that the speed with which they used to work to supply their supermarkets was dramatically reduced at that time. Workforce were able to work, distribution and warehouse operation were constraints. So basically, they have a problem with cash flows due to customers' payable problems. So there are so many problems in the warehouse. And that problems is actually transcended or transmitted along the supply chain until it reached the manufacturers. So the manufacturers itself, so this is a picture of Ford engine factories in one of the sites in the UK. They were, because they're not building cars anymore at that time, they were asked to build the ventilators, because at that time the need of ventilators are so much, and therefore they are asked to build the ventilators. But in terms of situation in the manufacturing is exactly the same as the warehouse, because everybody has to be able to work in a distance, and some of them, and many of the workers cannot work actually because they got COVID. Production was halted, factory was closed, workforce were laid off. In terms of suppliers, they could not supply the product. Suppliers manufacturing shifted from one plant to another, causing disruptions, and inbound and outbound logistics were also severely disrupted, delayed by closed of seaports, closed of airports. Until now, some airports in some part of the world are still closed. Yeah, so you can imagine the distributions in and out of that particular country is going to be affected by that. Now, coming out of lockdown, so two years later, we think that now we are kind of leaving the lockdown, entering the new normal, but actually it's still problematic, because leaving the lockdown is a process, not a sudden jump from one state to the other. So the question is, how do people operate, how do business operate in the realm of safe distancing and the use of extra protective equipment? Certainly for people working in the warehouse, this is going to be slowing down their job. Can they perform? So people in the manufacturing, operators, can they perform at the highest productivity? so that it can be competitive as before. So how do manufacturers rapidly ramp up the production after the lockdown? So these are all the problems that were faced by manufacturers and the supply chain when they're coming out of lockdown. So still not easy. We are still in the transition process. There are some strategies, if you like, on how to move towards more resilient supply chain. Yeah, and according to Keros, there are 6 strategies that manufacturers can do, particularly when they're trying to become more resilient. So they need to be adaptive. Yeah, so they need to focus on adaptation. They need to be able to recover quickly. So the companies who are adopting recovery focus, they will think that they can recover quickly. They need to recover quickly. Preparedness focus. So those companies who are focusing on preparedness, they need to be able to prepare for the next pandemic. Yeah. If they are focusing on disruption, so how they are navigating on this during the disruptions. And those people also thinking about, this is the time now for paying more attention on the sustainability. So environmental consciousness, humanitarian logistics, and so on. And finally, some of the companies also thinking that this is now the best time to move on towards the digital technology. So here we go. So these are the 6 choices that you or companies may follow or may adopt to become more resilient towards the pandemic. Well, certainly on this particular talk, I'm going to focus on the sustainability, because this is now, we are going to look into how companies implementing circular economy through the so-called business models. If you look at the literature, there are so many circular economy business models that will then focus on the sustainability. So I may not have time to go into detail on every single models here, but let's go through the first one called the dematerialization. So dematerialization business model means that whenever possible, we do not use materials to convey something. So if you want to watch movies, then you probably want to shift now from buying DVDs or Blu-ray, and rather we are using the Netflix services. So because when we do not use CDs or DVDs, then we do not need the materials to produce it. So nowadays we are reading news using our gadget that also coincidentally is a phone, basically, but this gadget can also be used as smart devices when we read news. Second business model is called product or service on demand, which means that this will support the idea of the first idea of circular economy, which is the resource efficiency. So if we do not need to produce a certain product, then we better delay it. So that's the idea of product or service on demand. So some business models that we can do is, for example, we have this additive manufacturing or 3D printing. Yeah. So in the past, when we talk about 3D printing, we're always talking about prototyping. We want to prototype something through these materials, the plastic materials. But nowadays, 3D printing has been developed so fast, we can even print metal powder. So this equipment here showing how to produce metal powders through 3D printing technologies. Hopefully you will be able to see that. I believe that the machine is called Mark Forged 3D printing. This machine can print metal powder of a wide range of materials, from copper to stainless steels. And I believe that many of the Formula One teams, they have this kind of technology to produce their spare parts. Right. So the third business model is the secondary or recovery of secondary materials or byproduct. And perhaps this is the most common business models that we have in terms of circular economy, particularly in the developing countries. And in Indonesia, for example, plastics, bottle plastic has been utilized, recycled, and made to many products. This is just an illustration, an example on how plastic bottles can be utilized as the raw materials for textile. So how plastic bottles can be used to make polyesters, shred it into flakes and convert it into pellets. From these pellets they make the yarn, polyester yarn, and then obviously from yarn they produce textile. Okay, so the fourth business model is repair, refurbish, and remanufacture. Again, there's a company in Indonesia I visited a couple of years ago, Komatsu. They are selling both brand new tractor and also remanufactured tractor. And the business model here is interesting because then the reman part or reman tractor will have slightly different inventory models, slightly different production systems. What interestingly is the company are selling both brand new and also remanufactured product. Finally, we have the so-called performance-based or pay-per-use, and this is typical in servitization or product service systems, whereby the manufacturers are no longer selling product, but rather they're selling the functions of that product. So typical companies selling product service systems are Rolls-Royce, Alstom, Caterpillar, Xerox. So Rolls-Royce nowadays, they are selling the service, or they're selling the performance of the aircraft engine instead of selling the engine. So they are maintaining the engines and they get revenue from the maintenance of the engines. Similarly, Alstom also selling their trains, 2 train companies in the UK. Caterpillar and Xerox also doing the same thing. So you might be thinking that, yes, they can do this business because they're selling expensive products. What about a slightly low-cost product, such as this Windows? Yes, it is partly possible. And this is the project that we tried with partners in Europe, with Delft, Leuven, Aachen, and also Leiden, and Tecnalia in Spain. We are trying to utilize or trying to invent a business model on how to create the so-called fashionable yet sustainable. As I said to you before in the beginning of my presentation, that aluminium windows is very robust, it's very strong, and therefore not fashionable, because it's impossible, it's not feasible that we can change this windows every 5 years, for example. But if we can find a business model whereby we can sell these windows as a service, then we can pretty much change the shape or types of windows that we have, so that then we can be more fashionable. So the type of windows that we're talking about here are windows with many functionalities and functions. For example, it's got a solar panel, it's got LCD, LED, and so on. So they can be used for multiple purposes. So the idea is that if we can find a way on how to turn these windows, install it quickly, deconstruct it quickly, collect it quickly, inspect, and then we can give these windows a second life or real life option by installing it in different buildings, then we can achieve, we can be fashionable, we can change, we can swap our windows frequently, and we can be sustainable at the same time. However, when we moving on towards the product service model, we need to think about the reverse logistics issue. Reverse logistics means that the opposite direction of logistics. So I said to you before, in terms of supply chain, we are trying to distribute the product from manufacturing to the retailers or to customers. And this is the reverse process of that, whereby we collect the end-of-life product from our customers, for example, from a building, and then we bring it back to our facilities, we do something about it, and then we immediately bring it back to the circulation. Yeah. So in this way, we need to think about, where is our facility going to be built? Is it going to be the same as our manufacturing facilities, our factories? What is going to be the inventory model? Because now we have spare parts from our existing suppliers as well as from our existing customers. So the second-hand parts that is going back to us is our inventory. Also, in terms of transport, what is our mode of transportation? What is the network for that? What is the pricing? How do we design the pricing for our spare parts? I mentioned earlier on about tractor manufacturing, Komatsu. They must have a pricing models for their remanufactured product. Now, in terms of sourcing, are we going to source it externally from our suppliers, brand new parts? Are we going to source it externally from our consumers? And if we outsource to our, if we source it from our consumers, then we need to do something about it. We may need to repair it and so on. In terms of forecast, is it going to be demand forecast? It's not going to be demand forecast anymore, because we can actually manage the demand. Yeah, because we know we are selling our product to a certain customers, and we know that we're going to get the spare part back in 5 years' time, for example. Other issues, for example, obsolescence and other risks that we need to think about when we do these reverse logistics, product services, and of course, the circular economy models. So, to summarize, circular economy, if you look at, if you listen to my presentations, it is not just about recycling. It is not about waste processing, because if it's processing, that means it's too late. It's not just about reduction of pollution and carbon footprint, and also not about green issues, but more importantly, it's about resource efficiencies, how we prevent the waste, how we create a circular process so that we can circulate our products longer, yeah, and how to map the material streams so that then we can recycle it properly. So for businesses, then we need to consider a few things. First of all, we need to consider the business model itself. So we need to be able to choose, we need to be able to develop our business model so that then it can support the circular economy. Then we have to design the product. You may remember I showed you attributes. So we need to think about attributes of the model that can lend itself for circularity. Yeah? And then we need to design the process. We talk about reverse logistics. We need to be able to design how we're going to collect the second-hand parts from our customers if we're selling it as a product service systems. So, and then when we sell these circular economy products that has been remanufactured, product that has been refurbished, we know that this is a second-hand product. How are we going to explain to our customers? How are we going to get their trust and image in our product? So, like I said to you before, Komatsu has done it. So they are able to convince their customers that although you are buying our remanufactured products, we are giving you exactly the same warranty, for example. And finally, we need to have systems, tools, and methods to help industry, to help businesses to be more circular. With that, I end my presentation. Thank you very much.
Thank you very much, Prof. Benny. Very interesting and insightful, specifically looking at the post-pandemic response and how we can use circular economy to boost our economy back. And I guess now it's time for Q&A. I'll hand it over to the participants, to our students, our alumni. Please raise your hand if you have a question for Prof. Penny. This is a very precious opportunity to be able to discuss Prof. Penny, because Prof. Penny has extensive experience both in Europe, in the UK, and in Indonesia. Okay, maybe if anyone wants to ask also their question in Indonesian, I think we won't mind, right? So don't be shy. Just go ahead and ask, and maybe before the students maybe want to ask a question, I have a quick question as well, Prof. Denny. I'm really curious about the design for disassembly attribute. I saw that there was a set of principles for the resilient supply chain management. How do you see this solution of pay per service? For example, the facade as a service as you mentioned. How do we integrate it back to the resilient supply chain management? And especially, I'm interested in design for disassembly because I guess that's the whole idea of the whole building. Yeah. Then the building needs to be designed for disassembly as well in the facade level. How do you work with the civil engineers and collaborate with all the different actors that may not be fully interested in this pay-per service approach? Okay, so quickly, there are many, obviously, then I wouldn't be able to explain every single ways of doing that, but I wanted to focus on one thing, and this is true when we did a project with the European Union, the facade reverse logistic. In Europe, they're trying to impose on standard. So having standardized size of windows and materials, that in itself imposed or enables, if you like, enables modular ways of building facade or building windows. I know it's probably simple, but then if we talk about standardization, we talk about many producers, big producers, they may not want to have standardized, because the reason why they are competitive, because they have unique features, they have unique sizes, they have unique ways of building things. And when they are asked to standardize their size and materials, then of course they don't want to do it. So that's in itself is a challenge on how to become more circular. And the reason is that if we make everything modulars, then it's a lot easier for us to change and swap and make it more circular. Of course, there are other things, Busindi, but unfortunately, I won't be able to have time to explain all of these. Yeah, thank you, Prof. And because I imagine there needs to be like a phasing out period where there are facades which doesn't come to the standard, and yeah, I imagine the practical level, it's quite complex. And also not only the standards for the product, but also the standard for assembling it, building it, constructing it. Yeah, if they do not have a certain way of building this, it would be very difficult for them to disassemble. Right? It may break. Yeah. So joining techniques, for example. So everything is there, isn't it? Yeah. Yeah, that's very interesting. Maybe I guess also here it's very relevant for the civil engineers in this conference. Absolutely. But also for the material engineers, industrial engineers. Yeah, there's a lot of roles involved. Sorry? The architect was in the architect as well, yes. True. Yeah, architect, because architect competitiveness is by selling the design, but sometimes there is what's the word, the paradox, yeah, between the architect and the builders. The architect
develop something that is nice and futuristic, but it's very difficult to be built in such a way that it can be disassembled. So there's a tension there.
Yeah. One thing that comes in my mind, Prof. Benny, is that in Indonesia, it is said that the payback period of a restaurant is 2 years. So usually people would invest in starting a restaurant, but they know that in around 2 or 3 years they would have to renew and refurbish or even remake a whole new restaurant. And I think this pay per service approaches would be really relevant for restaurant owners.
Absolutely,
it would be cheaper for them to rent. Yeah.
So those windows sorry, go on.
No, go ahead. No, go ahead.
No, I was just going to comment quickly on the windows with LCD and LED. So these are all display windows for shops.
Yeah. Great. So I guess the students are maybe a bit shy. Mas Ibrahim, do you have any question? Because you're turning on your camera. Or Mas Danang, Mbak Citra, Mbak Hafsya ada nih. Oh, ternyata jadi ada yang tunjuk tangan. Padahal waktunya udah mau habis. Ya udah, mungkin satu nih. Siapa duluan tadi? Mas Isnanta, Mas Agung, or Mas Isnanta, silakan.
Thank you, Bu Cindy and Prof. Benny. Thank you for your interesting presentation and topic. As your presentation is one of the focus to be more resilient is to disruption focus. And I see in your slide that there is a ripple effect control on that point. Yeah, one of the point is ripple effect control. Could you elaborate more or provide a sample about that one?
Yeah. So the ripple effect is the bullwhip effect. So the bullwhip effect means that along the supply chain, the demand in one part of supply chain cannot be read by the other part. So everybody is guessing, if you see what I mean. So that's why they have the ripple effect of that. Now, by using the technologies, for example, the technologies of in the supply chain, then we will be able to reduce the ripple effect of that. And this is usually on the technology focus. So now, because of the pandemic, they would be able to. Well, the idea is that those 6 points these 6 points are offered to manufacturers or supply chain on how to be resilient. And one of the ways to become resilient is by using the technology. And the technology is used to reduce the ripple effect of that by using RFIDs, for example, by using a more transparent way of knowing the stock or inventory and the demand from the customers. By reading their actual, by using the technologies, then the supply chain will be able to read a more true demand from the customers, if you see what I mean.
Yeah, thank you, Prof. Benny.
So it's just one of the focuses in terms of being resilient by using technology.
Yeah, thank you, Prof. Benny. I'm thinking in the same line for the environment. It's important to do real-time water quality monitoring, for example, so that you can control the pollution in real time as well. Okay, great. Mas Agung, I apologize. We don't have time left for question and answer, but you can post your question in the chat and maybe we can send it via email to Prof. Benny if Prof. Benny has a bit of more time, if you have some pressing question. And so before we close the session, on behalf of the Faculty of Engineering and the IESC committee, I want to thank you, Prof. Benny, so much for this opportunity, for the very insightful information, and I think this opens up opportunities for future collaboration between Coventry and UI, but also between the different departments. We see that the challenges here requires transdisciplinary approach. And as a as a token of appreciation, we present you our online certificate
Thank you.
for Prof. Beni Cahyono in recognition and appreciation of being our keynote speaker. We hope that this is as well beneficial for Prof. Beni and all the students that are here. And we look forward to future collaboration. Thank you so much. I apologize for the glitch in the beginning. I just borrowed my husband's computer and now it's totally fine. Thank you to my husband for his laptop. And thank you everyone for attending this keynote speaker, and thank you for all the hosts. So back to the MC.
Thank you. Bye everyone.
Yeah, thank you.
Thank you.
Terima kasih Prof. Beni.
Okay, thank you so much, Professor Beni Cahyono, for the incredible and insightful presentation. And also, thank you very much to our wonderful moderator for leading today's keynote session.
Next, we will continue our main agenda in the 7th International Engineering Student Conference 2022, the presentation or conference parallel session. The committee has already scheduled all papers into several parallel sessions. We would like ask all participants to consult your schedule and join the breakout rooms in accordance with your sessions. Thank you.
Thank you.